Hi there, this is Mr. Barron. Let's get rocking with number 29 in chapter 17. This is a very challenging problem because it requires you to apply some math skills you may actually haven't done before. So first off, I have the given information here. They tell you you're making a buffer at pH of 3.5, and they say pick between these different combinations of weak acids and their conjugate bases. So these are the acids, and then here's their paired up conjugate bases. Now the problem doesn't pair them up like this, but I do just so that I know that this is the weak acid for this conjugate base. Weak acid, conjugate base, and so forth. So you have to figure out which pair to pick, so obviously only one's correct. Well, one of the things that we need to understand is from the Henderson-Hasselbalch equation. pH equals pKa plus the log of your base, conjugate base, over your acid. Now, I often write just base over acid because this is known as the conjugate base over the acid. So when I look at these things, and I look at it carefully, any combo of concentration here, when you take the log of it, this number right here is going to be relatively small. It's not going to be that big of a difference. So whenever you're trying to make a buffered solution that has a pH that you already have desired, like 3.50, you want to pick your pKa to be pretty close to your pH. So look up the acids Kas and take their pKas. And when I go into the back of the book, the pKa for this pair right here is 3.74. I took the Ka, and then I took the negative log of the Ka of this compound right here in the back of the book. Then I have the pKa for this acid is going to be 4.74, and the pKa for this one is 2.12. So out of these three, the one that's closest to my 3.50 is actually this pair. So I'm going to use this one as my combination for making up my buffered solution. Then they tell you have 0.1 molar of each of these, and they're asking for what volumes to use. So let's actually plug in some numbers that we know about within our Henderson-Hasselbalch equation. We know our pH. Our pH is 3.5, so I'm going to write 3.50 is equal to, and the pKa for the combo we picked was 3.74, plus log, and we know it's going to be the concentration of the base over the acid. And I could be very specific, and for the base, I would write, instead of base, I'd be writing the NaCHO2, which looks like nacho, of course, and then HCHO2. All right, so that's where I need to start. I know the concentration I'm starting with, but I don't know the volumes I'm going to be mixing of each. And I know that it's a total of 1 liter buffer. So let me write this out one more time. 3.50 equals 3.74 plus log. And let's think of it this way. The base we know has a molarity of 0.1 molar. Okay? The concentration of the acid is going to be 0.1 molar. What's going to be different about them are their individual volumes. And the individual volumes is what you multiply it by to figure out the moles. So it's going to be times some sort of volume in liters that we're going to pick. Then we know we're dividing it by 1 liter because we're making a total of 1 liter solution for each of these things. They're going to be added together and be over 1 liter. Now, if I look at this mathematically, these two things are going to cancel out, no doubt. So cancel these out. But my question mark is, what goes here? Well, what do we know about the volume? Let's pick the volume for our base, which is the nacho one, as, let's call it just Y. So we'll say that the Y is the volume for nacho, which is the conjugate base, NaCHO2. And then we have to create a relationship between the volume of this one and the volume for the acid, which is the HCHO2, right? So what's the relationship between these two, keeping the same variable, y? Well, we can think about it almost in terms of like a percentage. Is that like, well, we have y, and then we have the other part to it as well, which is 1 minus y. So for whatever y is, 1 minus that, because we know our total volume is going to be 1 liter, that whatever this is, take 1 minus this, and then I know it's going to be the volume of that. Because remember, I can do this. I can set up this relationship between the two of those because I know my total volume is 1 liter. So whatever this is just 1 minus that, because I know my total's 1. So what goes in place here and here would be for the top one, it would be y, and the bottom would be 1 minus y. So I'm going to rewrite that down here below. So 3.50 equals 3.74 plus log, and on the top one it's going to be 0.1 molar times y over 0.1 molar times 1 minus y. So now I've got some math to do, because I have to obviously solve for my y's, and then I know the volumes. So what I can do is I can take the difference between these two. I could subtract this to the other side, and I get something like negative 0.24. What is it? Am I doing my math wrong? 244, I believe is right. No, I'm way off. I'm going to pause this. Something's wrong with my math. All right, I'm back. When you're doing a complex problem, I just want to show you how you can go brain dead. First off, that's easy subtraction. I have no idea why that took me so long. So anyhow, there we go. Took this to the other side. I got minus 0.24. And what's that going to be equal to? The log of this thing again, which I'll write down a little bit more simplified. And it'll be 0.1 y over 0.1 minus 0.1 y. Why did I write it out like this? Well, 0.1 times 1 is 0.1. 0.1 times y is 0.1 y. So I dropped the molarity because it's not going to matter when we do our math as far as the units are concerned. And we know the log is base 10. So we know that 10 to the negative 0.24 is going to be equal to 0.1 y over 0.1 minus 0.1 y. Now you have to take this and you're going to have to solve for y. When you start doing that, you end up with a whole mess load of numbers. You're going to have to take this whole denominator and multiply it by this number and start combining like terms. Once you get through combining all of the like terms, and I don't want to spend all the time doing the math on this because I think for most of you would start using your calculator at this point, your y ends up being 0.363, which means if we take this information, your y, we now know our volume for Nacho, 0.363 liters. And because Mr. Barron is quite out of it, he's actually going to bother to type in 1 minus 0.363, and sure enough, my volume is going to be 0.637. So there we go. We've got our two volumes. Pretty long math problem. I would say this is about as advanced as it gets. It's a good one to try. If you have any other questions, please let me know.